We will see why LTE based solution for IoT connectivity is broadly preferred over other solutions. That is because of the following reasons that are present here. First one is ubiquitous coverage. There are already established networks for LTE ecosystem which are serving already billions of connection worldwide. So the coverage is already present for LTE ecosystem, and the deployment will be just a software upgrade. And the scalability of LTE devices is also an added advantage. Based upon the type of device that is going to connect to the network, we can provide that much amount of bandwidth or that much amount of physical resource block for that particular connection link. And obviously, uh, the amount that needs to be paid for that particular link is also dependent upon the scale of the network, that is the scale of the communication link that is being provided for that particular IoT device. So it provides gives us a option like uh, pay based upon how much you use, so that it is easier for the deployment persons to consider the amount of data that the particular thing is going to need and plan accordingly through LTE IoT networks. And coexistence is also a important benefit that because on from LTE IoT specifications. That is, it actually leverages existing the plan and use infrastructure and spectrum. So we don't have the operator had or the person who is deploying this IoT network, or even the network operator does not have to purchase a new band of spectrum to separate this IoT connectivity. And it has even the seamless interoperability, because it's already a LTE is a mature ecosystem backed by global standards. And managed QoS based on the licensed spectrum with a redundant network design, we can even manage the QoS that is needed for the particular application through LTE IoT network by choosing wisely the amount of bandwidth that it needs. And we can even provide the end-to-end security because the already established and trusted security algorithms are already present in LTE networks. We can utilize the same thing for the IoT device because the authentication feature is already built in the IoT networks. It's just a graphical representation from to compare between the various LTE technologies when from performance as well as coverage perspective. If you see the traditional LTE devices that we have, that is LTE Cat 1 devices and above, that is category 1 devices and above, they actually use the bandwidth of n into 20 megahertz, depends upon how many carriers that we are using the carrier aggregation technology. They utilize that much amount of bandwidth, and they usually provide greater than 1 Mbps link. That is, we can able to provide get more than 1 Mbps in both outlink and uplink and downlink. And if you see the IoT technologies that we have discussed before, that is LTE Cat M1, LTE Cat NB1. Uh, LTE Cat M1 provides the coverage enhancement of 15 dB plus, or MCL value of 15 dB more when compared to LTE networks. Of course, it comes with a cost that the amount of speed that we get through this LTE link is around 1.4 megahertz, and it can perform up to 1.1 megahertz 1 Mbps downlink speed. It has comparably faster data rate when compared to NB1, and the coverage is lesser than NB1, and it can even provide the voice over LTE support as and voice link kind of applications over this particular network. When it comes to NB1 network, it utilizes just 200 kilohertz of spectrum, and we can expect around few tens of kbps speed through this link. And it's ultra low cost network and ultra low power, and it even delay tolerant network. We can even get the enhanced coverage level even 5 dB more than the cat m1 kind of devices. Of course, it doesn't come free of cost. We have to compromise between the performance. Usually for deeper or denser deployment where the things are present in underground underground areas to measure the moisture level of the soil or humidity levels of the soil, etc. In the deeper coverage area, this Cat M1 devices are preferred, whereas for normal applications, Cat M1 sorry Cat NB1 devices are preferred, whereas normal applications Cat M1 devices are preferred. And for normal computing purposes, we usually prefer LTE Cat 1 above devices. Cat stands for actually category. Yeah. When it comes to when it comes to IoT devices, what are all the changes that went in when compared to traditional LTE networks is explained in this particular slide. The signaling has become more efficient in IoT networks because uh, in traditional networks will support few hundreds of devices in one particular cell, but now it is number of the devices that is going to connect to the network is has increased drastically, as we expect few thousands of devices or even lakhs of devices will be connected to a particular network in the LTE network. So to support the larger number of devices per cell with new features, uh, to some new features such as group-based paging and messaging has been introduced to support this many number of devices together on one particular network. The core network is actually simplified because we don't have that much number of bandwidth. I mean, we don't have that much number of broad data that is going into it. So the core network functionality has been reduced, and specifically in NB1 network, there is no mobility that is present because it is actually the network is designed for less mobile devices. So the role of MME particularly will get reduced. MME may not be present or may not. I mean, most of the functionalities of MME when compared to traditional networks is limited, and many I mean since it became less, uh, it makes it possible for integrating network functions into a single entity. So resource management has also been increased, that is enhanced resource management. They have made few optimization even in resource management domain to allow actually a large set of devices to share the same subscription. That is, all the water meters in a city shall share the same subscription identity, etc. Uh, the core network node involved in EPS architecture optimized for CIoT, that is cellular IoT, can be deployed as a dedicated core networks within public land mobile networks. I mean, here the EPS architecture has been optimized for cellular IoTs as well. So depends upon the kind of application, depending upon the type of object that we are going to that is going to connect to the network. Any of the kind of networks can be preferred. For example, if a particular connection link expects more than 10 Mbps and above, a Cat4 network can be deployed or Cat4 technology can be used. And uh, for normal one single user communications where not much data traffic is expected, we can go for traditional LTE Cat1 devices. It can support up to 10 Mbps with just 20 megahertz bandwidth. As we have discussed before, if uh, we need to connect lower data rate even around some 1 Mbps data, we can go for category -1, that is EMTC networks, which can be supported over 6 PRBs, that is 1.4 megahertz narrowband network. And even for deep, if we need deeper coverage and lesser data rate, the way the coverage is the main concern when it compares to the data rate, we can go for LT Cat NB1 or NB LT Cat NB1 kind of networks where just 200 kilohertz bandwidth is used and it can provide around some tens of kbps. So where and all these kind of networks can be deployed is show in this slide. You can go over this particular slide. We'll see something called as small cells is also being discussed in release 13 3GPP specifications for LTE IoT deployments. Small cell is such a kind of thing where a particular node will act on behalf of all the nodes to the cellular network. So what are the advantages if we use this kind of small cell kind of LTE IoT deployments? It will actually improve the coverage uh, because a particular node which is very close to all the devices is present and it communicates with the network on behalf of all these nodes. We can provide much more connectivity to this to the devices that are even present in areas such as buildings, residential, or industrial areas, etc. And it can we can even have the longer battery because the node is present so close to the devices so that the devices don't have to transmit much of the power from their uplink side, so the battery will also stay for a longer period of time. And we have few deployment options such as utilization of unlicensed spectrum at the devices end, whereas it uses the licensed spectrum for communication between the network, and even it can share the network. I mean, it can even share the network among all the hosts using unlicensed ways. So one example of such deployment is multi-fire. So this is about one way of LTE IoT deployment, which is compared to Wi-Fi, where we'll have a dedicated node present near the devices, and it can communicate between the things, and it will communicate to the network on behalf of the things that are present connected to it. So, when to choose what kind of network is actually the deployer choice. The advantages that LTE release certain IoT technologies that is present are single. It's actually based upon the radio access network has been uh, optimized, and we just need a single LTE RAN network and core to operate and maintain. We have seen the optimizations that have been went through, and it has even higher spectral efficiency. Since the network is already present widely uh, over the world, it is even possible for mature testing and the devices OEM ecosystem due to standardized model. We can leverage the existing network for the deployment. So these are the advantages that LTE release certain IoT technologies that will provide. When it comes to spectrum choice, for all the mission critical IoT, it is recommended to use licensed spectrum because we don't have to take the risk of getting tapped in the unlicensed spectrum. So license, we know that the proprietary technologies such as LoRa and Sigfox operates in unlicensed spectrum. So for mission critical IoT solutions, it is preferred to use licensed spectrum. For non-mission critical IoT spectrum, it is IoT needs. It is up to the network operator, or it is up to the deployment agency. They can use whatever the shared or unlicensed, I mean licensed or unlicensed spectrum. If the particular application needs a TDD spectrum, and if it is licensed, or even if it needs just TDD spectrum, only Cat-M1 will provide the necessary link, because even the NB1 and other Sigfox and LoRa doesn't support this TDD way of functioning. When it comes to FDD spectrum, we can choose between both, either Cat-M1 or NB1 as they support both. If it is legacy LTE and IoT, I mean both needs interoperability. One-on-one overlay of IoT offers significant coverage advantage because both the networks will stand together